All right. Hi, everyone. So we're going to continue kind of where we left off on Tuesday, where we went over the introduction to Pandas and we kind of went over the presentation. Except this time, we're going to go over the homework and kind of work through it along the way. So if you have any questions or just would like to hang out in the stream or just like work alongside us, feel free to join the StreamYard link if you have it, and also just message any questions in the chat if you have any. All right, so without further ado, we're going to start off on the homework. I'm gonna copy and paste the link in the chat for anyone if you don't have it already. There we go. But yeah, so we're just going to start off with the homework, and this time, instead of using a data set based on the Titanic, we're going to be using a data set based on the US Census, and then make some basic Pandas functions and just do some basic cleaning and manipulation of the data. So to start off, we're just going to press this first part, which is we're importing the library Pandas. It's going to give you this warning message saying the notebook was not authored by Google. You're just going to run it anyways. And then, as we remember, like before, what we're doing here is we're just importing the Pandas library so that anytime we reference PD, we can reference and access any of the functions inside the Pandas library. So once we've imported that, then the next thing we're going to do is load the data set. So the URL and the most basic parts of importing and loading the dataset has been provided, but as a quick reminder, what we're doing again here is we're just accessing the URL with all of our data, and then we're telling Pandas to read the URL and read the data, and then put it in a data frame, or put it in this table right here. And then once you run that, then it should show you this big data set, which has 3,220 rows and 37 columns. Once you've done those preliminary steps, then we can get started with homework questions. So the first thing, really quickly, as not really a homework question, but kind of just to give you a preview of what information the dataset has, is there's this line of code that just says df.head, and then what that's going to do is just it's going to give you the first 5 rows of the dataset, and as you can tell, it basically shows a bunch of counties in a bunch of states. And then within that, it's going to show the general race demographic of this county, as well as the number of citizens, the average income, income per capita, the poverty rate, the child poverty rate, as well as the percentage of people who carpool, who drive, who walk, or use other transportation, as well as a bunch of other information about unemployment, about what type of employment people have, all of that good stuff. But yeah, just take a second to kind of be familiar with the data set, as once we do that, we're going to move on to actually working with the data set, cleaning it, and narrowing it down. Once we've done that, we can move on to question 1, which basically asks us to list out all of the column names of DF. So there's a variety of different ways that you can get all these column names up here, but can anyone think of any just like off the top of their head? Honestly, the best way to go through this is kind of just like run through the presentation or run through your notes, as all of the functions are right here. So it's going to show you a bunch of information about those basic functions. And I'm pretty sure the homework follows the general order of the presentation, so it's going to show all of that information as well. So there's a lot of ways you can do it, but one of the ways that is probably the most obvious, as it's right within the presentation, is just using the info function. Doing so is just going to show you all of the column names of DF, and it does give you some additional information, but in general, that also works as a way that you can get all the column names of DF. And then, as always, you're just going to be following the format where you have the data frame first, or the name of the data frame. In this case, it's just df, and then the function you're using. In this case, it's just going to be info. And then when we run it, we'll see that it gives us this whole list of columns. And there are some other ways to do that. If anyone wants to volunteer them in the chat or just join the StreamYard and say this verbally. But yeah, other than using the info function, which is probably the most obvious one here, you can also use df.columns, and this will show you as well a list of all of the columns. And this one isn't kind of like explicitly said within the presentation, since it's more niche and you don't really need to know it, but it is just another way that you can get all of the columns available here. But either solution works. Anything that you find easiest, all works there. All right. Any questions for question 1? Honestly, for like a lot of the first like couple of problems, it's really just about like being familiar with the like functions, as well as just having those resources on hand so you can look through it and then find which one can solve your problem or solve the question the easiest. All right, if not, we can move on to question 2, which asks you to set county ID as an index for DF. And right under there, it'll also tell you that you can use setIndex as the function to do it. All right, so any guesses on how to do this problem? Again, you can message in the chat or just really do anyway.
So would it be the like df.set index parentheses like keys equal county ID?
Mm-hmm. Yes, exactly. That's correct. You would just be using df.setIndex, as that's like pretty much the only function that can apply here. And then within here, or actually the handy thing about Colab as well is that when you put in a lot of functions, it'll show you like information about the function. But like it says here, you're just going to put keys equals county ID, which is spelled that way. And immediately that way it will set your index. But there's one more thing that we're forgetting in order to make it permanent. Can anyone think of like what thing we have to add at the end in order to make it permanent? We just have to put in place equals true. So basically, just by adding comma, in place equals true, then that way this will make the change permanently in your like data frame. And you can just call data frame again, and then it will show your change. Oops, hold on. Oh, yeah, because we already did that again. Okay. Well, now that it's been made permanently, then we can see that now the next time we call data frame, we'll see that the index has been set to county ID and that change has been made permanently. But here this time, since we tried to run the code block again, there's no such thing, or the index has already been set as county ID, so it's just redundant and we're going to get an error. Okay. Any questions for question 2? All right. If not, we can move on to question 3a, which asks us to find the rows where unemployment is greater than 10. And this time it's asking us to use the function df.loc. So how we can do that again is we can kind of basically just refer back to the slides, especially when you're starting out, as doing so will make it much easier for you to figure out how to use the functions. But I think right around here, find the rows where unemployment is greater than 10. So already when you look at the question, you can kind of figure out like what the question wants you to do. It's giving you a specific like condition, and it's asking you to find that condition. So I'm not sure exactly where the slide is within the presentation, but as you'll recall, when you look at the presentation, how DFLOC works is that within LOC, in square brackets, it's going to ask you to look for a specific condition and then try to put that condition in, and then LOC will show you that specific, or like any of the rows that apply to that. So I can put in the basics of it. So df.loc, and then does anyone want to guess what we would put in within the square brackets? We're basically just trying to put the like condition of unemployment greater than 10 within the square brackets in order for it to work. I can start off by putting df employment, and then can anyone think of what else goes in the square brackets? At this point, it's just the greater than 10 part. All right, well, the question's basically like already there, but you just have to put in greater than 10. You can put spaces if it looks nicer that way. But once you do that, then DFLOC, DF unemployment greater than 10, is going to show you any of the counties for which we have this condition, DF unemployment is greater than 10. And then you can also note down below, it'll show you the number of rows and columns, and then therefore it'll show you the number of rows that actually apply to this statement, which basically tells us out of like 3,220 counties within the data set, only 346 counties actually have unemployment rates greater than 10. All right, any questions for question 3A? All right, if not, we can just move on to question 3B. Okay, so question 3B is basically going to be the same one. It's going to ask you how many counties have unemployment is greater than 10, and then just wants you to type your answer in the answer section. And then the hint asks you to look at how many rows Q3A displays, and then like we said, we can just go down here, and we can see there are 346 rows, which all represent 346 counties. So down here, we can just put 346. Then you can run it if you want, but it won't really do anything since there's no code there. Okay, any questions for basically the entirety of question 3? If not, we can move on to question 4. Once you get to question 4, it's going to kind of get a little bit more difficult, as right here, we're going to start doing the questions where it's going to ask you to put multiple parts together. So earlier, we've kind of just been using like one function at a time, but at this point, it's going to ask you to find the state with the most self-employed population. So it's going to basically ask you to do multiple components and use multiple functions in order to get this one state with the most self-employed population. So can anyone think of where we can start off as the first bit of figuring out, for example, like how to sort the states or how you want to arrange it? A resource that we can use, again, as always, is just the slides. The group by function should be somewhere around here. Okay. Hold on. Okay, so this one is kind of like going to hint at what we're doing, but as you'll recall, the group by function basically allows you to group and compare all of the different data sets or all of the different data points within the data set by a specific variable. And then beyond that, we can use an aggregate function to try and figure out what variable we're trying to figure out. In this specific example, we're just using the mean to find the averages of all of these things, and then we group all of that by this specific variable. But can anyone think of how we can use those functions to answer question 4? You'll notice that there is like one thing that's going to like basically be common within all of these. So earlier, a lot of the passengers had the common trait of being either female or male, and that allowed us to group by like sex. But what can we group by here for like what common thing can we find to group by for these counties? The answer is going to be basically how those counties are divided, and it's basically going to be state. You'll notice that, like, for a lot of these, all of them are grouped by state, and it's all organized by state. And similarly, within the question, it's asking you to find the state with the most self-employed population. So because the county, it's like all the data points are separated by county, the first clue of how to solve the question is going to be using the group by function and grouping it by state. So to start off, we can just put df dot group by state. And then the next part that we're going to look at when we're trying to answer the question is we're trying to answer like what specific variable we're trying to solve for. So specifically in this case, we're solving for self-employed, and we're trying to rank it in order to find the state with the most self-employed. So in order to do that, we're just going to put in the variable that we're working with. In this case, it's self-employed, but it really could be any of those. And then just checking really quickly to make sure we get the name of the column right. Okay. Okay, so it's just called self-employed. So we're just going to put self-employed. And then finally, once we've basically told Pandas or the IDE to group all of the counties by state, and then also look specifically at self-employment and get those statistics for that state with all of their combined counties, then the last thing we need to do is we just need to figure out which functions that we're using in order to figure out like the state with the most amount of self-employed people. So in order to do that, the last bit we just need to add is sum. And then finally, once we've gotten the sum of all this information, we can just use sort. And then in order to make it all from like greatest to least instead of least to greatest, then we just have to do one more thing, which is to add ascending false. So it's actually not sort. I think it's actually sort values, since you now have been given like a specific value based on sum. So you're just going to use sort values, and then ascending equals false. And then, as always, often you're going to be encountering errors, but don't be discouraged by this. Just make sure that you fix it. Okay, hold on. I think ascending just needs to be like this, and sum. Oops. Oh, I think false needs to be capitalized. Okay, so there we go. So a lot of times there can be like little formatting issues when you're going through the homework. The best thing you can do is just like keep on experimenting. Basically here, what we've done now is that we have sorted all this counties by state first. So we've combined all that information. And then we've asked them to take the sum of self-employed. And then finally, we sort the values by sending equals false. And then we get our answer. And as you can see, Texas has the highest number of people who are self-employed. And it's kind of like a complicated solution, especially when you compare it to like the previous questions we work with. But in general, the best thing that you can do is just like keep practicing at it and also just keep experimenting with it. Like we saw earlier in the previous examples, how you're going to generally solve a lot of your problems is just going through the like actual presentation and then seeing how other problems are solved. And in general, that's going to involve using multiple parts. Like for example, in here, we're basically doing the same thing where we're creating a custom filter first, and then we're giving it a name, but then we're asking it to look at survived specifically, and then using an aggregate function to find the mean. And then here we're doing the same thing where we're grouping all of that information by sex first, and then we're finding the mean. Except here, we're kind of taking it a step further and doing multiple components where first we're grouping it by state. So we put all the counties within their state. Then we're looking at self-employed and getting the sum of all of that information. And then finally, we're doing sort values, ascending false, get greatest to least. All right. Any questions just for this specific solution? All right. If not, we can move on. And then here it just wants us to type the answer in a string form. And basically the solution is just going to be, you're going to like literally type the answer. As you can see, if you go up, it's Texas. So you can just type Texas. You should probably put parentheses around there. And then that way you just have a string that says Texas. But yeah, here it just wants you to grab the state with the highest amount of self-employed and then put it in quotations so it's a string, and then you have your answer. Okay, next we can move on to question 5. And question 5 is asking us to select the state with the most self-employed population and save the data frame as DF self-employed. So basically, we're kind of doing the same thing earlier where we're using the DF LOC function to narrow down the data frame only to data points that fit a specific condition. And then finally, we want to save the data frame as a completely separate thing. So to start off, we can use the df.loc function again. And then can anyone think of what condition we should put in the LOC function this time? We can recall that we're just trying to find, we're only trying to look at the state with the most self-employed population, and then the answer to, or the state that has the most self-employed population is Texas. So we're just trying to find a condition so that for whichever county, the state that it has listed as is Texas.
So can you just say state equals Texas?
Yeah, exactly. We just have to do df state, and then to do equals Texas, we just do the double equals, since if you'll recall from Python, just a single equals means assigning, but we're just going to do double equals Texas. And then that way we have our LOC condition, except you just have to remember to add rotations. And then that way we have our condition. And then now it's basically going to give us any of the counties that just have their state as Texas. And then lastly, we just have to save it as a new data frame, and it actually gives us the name already. So we're just going to put df underscore self-emp for self-employed. And then now we have a new data frame that has been based on our LOC function. And then it's not going to display anything just since we only assigned it. So if we want to see it, we can just do df self emp. And then that way it will show us 254 counties, and they're all from Texas. Okay. Next, for question B, it's going to ask us to find the two most popular means of transportation to work in df self emp, which is the data frame that we just made. And then this time, it's going to ask us to use the following columns: drive, carpool, transit, walk, other transportation, work at home, and an aggregate function. So again, this one is a little bit more of a complicated problem, but we can kind of basically take inspiration from our previous examples and then kind of see how we can do it. So as you'll see here, it's asking us to find the top two most popular means of transportation, and then basically just find like the aggregate function by like adding that all up within Texas. So all it really wants us to do is just to add up the sum for each of those different columns. So as we'll recall, we just have to use, like, for example, we just have to use the format of specifying our data frame name. In this case, it's data frame self-employed. And then we just have to put our column name in order to get our column name and the aggregate function we're using in order to get what we want. So in this case, for example, if we just wanted to use drive, then what we would be doing is df self emp, then drive, and then sum, and then that would give us the total number of people who are driving to work. And then that gives us that number. So can anyone think of what we need to do just in order to get all the rest of these columns of information available?
Well, could you just do the same thing for all the different kinds of transportation listed here?
Right, yeah. We could literally just copy and paste like all of the code again, and then we would just replace drive with carpool, and then with transit or with walk, etc. But another way we can do it is we can literally just put another square bracket in there, and then we can basically just comma and put all the columns that we want to look at. So we're going to put in carpool, and then comma transit, and then walk, other transp, and then finally work at home. And then now when we run it, it should give us the sum for all of the amounts of people who drive, carpool, transit, walk, or use other transportation, or work at home within the state of Texas, or within our custom data frame. And then finally, once we've done that, the last thing it wants us to do is basically just type the answer in a string form again. And we can see that the most popular means of transportation in this case are drive and carpool. So we can just put drive, carpool. And then you'll also notice that over here, it's like basically just putting the sums there. But another exercise that you could think about is that if you wanted it to be sorted in a certain order, like for example, right here from greatest to least, then you could just use sort values, and then it would do the same thing as earlier. Okay, any questions for question 5? All right, if not, we can move on to question 6. So basically for question 6, it's asking us, what are the top 3 states with the highest mean commute? This one is going to be pretty similar to question 4. And if we recall how we do this for question 4 is we're using group by for state, we're specifying what column we want, we're using sum, and then sort values ascending equals false. Except this time, we're just trying to look for the top 3 states with the highest mean commute. So we can kind of basically copy the format that we did earlier. As you'll recall, we'll do df.groupby. We'll specify that we're doing it by state. And then, can anyone guess like what we're going to put here for which column we're looking at. You'll notice earlier when we're using the same format, we're using group by state again, except in order to find the state with the most self-employed population, we're just using the column self-employed. We're just going to be using mean commute. So I think the name is just, or hold on. The specific one we're looking for is just mean commute, and it's just types like that. So we're going to put mean commute, and then now we're going to basically tell all of the data to be grouped by state. And then furthermore, we're only looking at the data regarding mean commute. And then lastly, in order to get the states to add up all the county information and add up the mean commute time for all the counties within state, we're just going to, like before, use the sum function. And then finally, like before again, just use the sort values function. And then again, ascending equals false. But I think ascending was lowercase, but let's check. Yeah, it was lowercase. Okay, so once we've done that, we can just run it. And then like before, we're going to get a list of all the states and then their mean commute times added up based on all the counties within the state. And it's going to sort it by greatest to least. And in this case, Texas is up there again, then Georgia, and then Virginia. And then finally, to put the answer in a string form, we're just going to do Texas, Georgia, and Virginia. Yeah. And then now we have our answer in a string form. So like before, we're just grouping all the counties by state. Then we're choosing to only look at mean commute and get the sum from this. Then we're going to sort the values by ascending equals false. And then that way, it's going to show us all of the state information based on mean commutes and then sort it from greatest to least. It's basically kind of a repeat of question 4, but it's just good practice to be aware of how to use the group by function, how to use the sum function, and then the sort values function to figure out that information and arrange it as you please. Okay, and then finally, moving on to question 7, or not finally, because there's
Sorry,
still...
can I ask a question? This is about question 5. What did you define, like how did you define df underscore self underscore m? Because when I ran it, it says it's not defined.
Oh, if you're having errors here, like around here when it's asking what df self-employed is, you just have to make sure earlier in the first part that you make df self-employed equals df LOC, df state equals Texas. So we're basically just taking a like specific subset of the data frame and then we're assigning it to a new data frame so that every time we call this name, it's talking about just this set of data. It might be something with like running the code blocks. Like if you put the code in here, which is basically the same thing, but you didn't run it and you just skip ahead, it might ask you what df self-employed is since it hasn't been defined yet.
Okay, sure. Thank you.
Yeah, no problem. Does it work now that you like ran the self-employed part?
Well, let me try because I don't think I ever defined it. Yeah, now it's working. Okay.
Okay, cool, perfect.
Thank you.
But yeah, you just want to make sure that you run the code blocks when you're defining it first. And then that way, the rest of the times when you're referencing df self-employed again and using these aggregate functions, the IDE and Colab knows what you're talking about. But yeah, okay. Any other questions for like literally anything we've covered? It can be like a general question about the topics or the functions we're using, or just any like specific part of the homework. All right, if not, we can move on to question 7. So this time for question 7, it's asking us to select the subset of data where state is the one of the states that we found in question 6 and save it in top 3. So basically, we saw that in question 6, we were looking at Texas, Georgia, and Virginia, except we want to save all that information as basically a new data set. So this is going to be taking after question 5, which we went over, where we're going to be making a new data set, except this time we're going to be looking at 3 states instead of just Texas. And the hint that it gives us is that we want to use the ISIN function. And basically what the ISIN function is going to do, if you recall, is it's going to only select the part of the data set that has a specific value based on whichever column you give it. So for example, if you gave it DF state and then .ISN Texas, Georgia, and Virginia, it's going to only show you, or it's basically going to look for all of the counties where the state is Texas, Georgia, and Virginia. So it's just another way to set the condition that we saw earlier. But if you can guess, it's basically going to be using the same format that we saw earlier, where we're using the LOC function to set the condition, except this time we're nesting another function within there, which is the ISN function. So in order to do that, as before, we're going to set the name of the data set we're referring to. So this time it's going to be top 3 instead of DF self-employed. And then after that, we're going to put df.loc, and then within there, we're going to put our specific function. This time, it's just going to be df state ISIN, and then can anyone guess what we're going to put in the parentheses for ISIN? We're just going to be putting in the names of the states. So like we said before, it basically works like the equal sign condition that we did earlier in question 5, except this time we're using multiple states, so we're using a function to do it instead. And in order to do that, we're just going to use square brackets again, and then within there, Texas, Georgia, and Virginia. And then now when we run it, it should give us top 3, or it's not going to give us anything since we didn't ask it to display it. But when we display top 3 again, we'll see that now it's basically showing all the counties that are within Georgia, Texas, or Virginia, which is 546. Okay. And next for question 7b, it's going to ask us how many counties are there in the top 3 states. And it's going to give us a hint to use one of the aggregate functions, sum, mean, or count. So this is going to be, again, like kind of similar to like the questions that we did earlier. Can anyone guess how we would format the code? We can start off by using top 3, but can anyone guess how to use the aggregate functions that we're looking for? Also, the answer is low-key there. It's already like 546, but in terms of code, it's basically going to be using the information that we saw earlier, where we're looking for which column that we're looking at. So in some cases, it can be state. In this case, it's county. So we're just going to do top 3 county. Oh, and you have to spell it right. So it's going to be county. And then lastly, we just want to use any of these aggregate functions. Can anyone guess which one that we can use? all of them work in like kind of a roundabout way, but there's one that's going to be like relatively straightforward. It's just going to be counts. So the other ones are going to give you like basically the same answers, but just using count is just going to look for how many counties there are, or how many times there's a value for county specifically in the data set. And then it's just going to use count, and the answer is 546. And then lastly, it just wants the answer in a string form, so we're just going to put 546. Okay. And then finally, for question 7C, it's going to ask us to find the county with the most mean commute time in top 3. So can anyone guess how you can solve this problem? You're basically going to be using the sort values function again, except this time we're asking the sort values function to sort it by something specific. And the format is basically already there. So we're just going to use top 3 sort underscore values. And then can anyone guess what we're putting equal to the by? To translate this into like plain text or like just speech, we're basically telling Python or Colab to sort all the values within the top 3 data set by a specific column. We're just going to be using mean commute. So like the question says, we want to figure out the county with the most mean commute time. So in order to do that, we're just going to be using the sort values function as the hint suggests, and then we're going to ask it to sort by the column mean commute. Then once it sorts it, we'll see that Kent County is at the top, and they have a mean commute time of 7.7. I'm not sure like what particular unit that is, or actually no, 7.7 seems to be the least. Since we didn't put ascending equals false, so we actually have to go down to the bottom, and then we can see that it's actually Virginia Westmoreland County, and they have a mean commute time of 41.5 minutes. Okay, and then so we're just going to put Westmoreland County. And to put it in a string, again, you're just going to use quotation marks. And if you want, you can also put the state, which is Virginia. Now you have the county with the longest commute time. Okay. Any questions for like question 7 or any part of it? You'll see by the end, a lot of the questions we're going to do are basically going to be building on the skills that we were using in questions 4 and 5, and basically in the very beginning of the problem set. All these questions are basically just combining a bunch of different parts, whether it's group by or using an aggregate function, or just sorting it in order to find the information that you want. Okay, I'm going to now move on to question 8, which asks us to find the top 5 states with highest income level, and then find out their top professional working fields, whether it's professional, service, office, construction, or production. And then this question is also a combination of questions 6 and 7. So basically, we want to figure out how we can use the answers of questions 6 and 7 in order to find the answer here. So can anyone think, given the answers of question 6 and 7, how we can answer this? I can even like copy and paste the outputs or like the code that we use for question 6 in order to kind of figure it out. So we can put it down here. And then for question 7, you can just take like this part basically, and then we can add it here. So can anyone figure out how we can combine these answers in order to solve question 8? Okay, so maybe it'll help if we can kind of figure out how we can split the problem into 2 parts. So the first thing it asks us is to find the top 5 states with highest income level. So we can start off with that first bit. Can anyone think of how we can use this first part by using question 6's answer to just get the first part of question 8?
Just change mean commute to income?
Yeah, exactly. We're just going to be using basically the exact same code since we're doing the same thing, except this time we want to change mean commute to income. And then once we do that, we can see that we have the states sorted by income from greatest to least, and the top 5 states with highest income level is going to be is going to be Texas, Virginia, Georgia, Illinois, and Iowa. Okay, so that solves the first part of the question. And then the next part that we want to do is to find out their top professional working fields. So can anyone figure out what we can do in order to just separate the data set that involves those first 5 states? And this part is going to be pretty similar to what we did here in order to get top 3. So I can also put that down in a comment. Oops. I'm going to take a second to turn on the light and grab some water. But yeah, give me 1 second. Okay, so yeah, moving on. Right, so like, how can we use the answer of question 7 in order to find question 8? We're basically going to be doing the same thing, except we're changing the name of the data frame, and then we're replacing Texas, Georgia, and Virginia by the top 5 states here, which is just going to be Texas, Virginia, Georgia, Illinois, and Iowa. So we're just going to give it a name. In this case, we can say like highest income or something. Or yeah, we can do top 5 income to be consistent. Equals df.loc, and then we're going to follow basically the same format, except df state Bison, and then within parentheses, we're going to put in Texas, Virginia, Georgia, Illinois, and then Iowa. Okay, so once we've done that, we've kind of done most of the work for question 8. We've created a way to figure out the number or the top 5 states for highest income. And the next, we've also separated our data frame so that we're only looking at those 5 states. And the last thing we're going to do is we're going to find out their top professional working fields. And basically, this is going to take inspiration from here, except this time we're going to sort values, except we're going to do a couple more steps in order to get there. So for example, previously we did something where we sorted values in order to find it, except this time we're going to be using the aggregate function instead. And then we want to look at what working fields or what columns that we're looking at within there. So in order to do that, we can just do top 5 income. And then in order to figure out the sum of that information, it's basically going to take inspiration from earlier. I'm not sure exactly which problem it was, but we're just going to figure out which columns that we want to look at and get the sum from. So like before, we can just basically put it in there, like whichever columns that we want, and then that will show you the information that you need and ask Python to sum up the amount of people that are working in all of those fields. So then you can just do reduction, or once you put in all of those like working fields, then you just can use the sum function, and then you can also get rid of this part since it's kind of served its purpose. Hold on, top 5 income, professional service. Okay, let's see. Oh, I think we just need square brackets again. And then, yeah. So we just need more square brackets to cover what we're looking at. Oh, curly brackets. And then that way, now, when we get the sum, we'll get the sum of the most popular sectors within the data set. So we're going to get professional, service, and office, and construction and production, basically all added up within the data set. And then what we'll see is the top professional working field is just going to be professional. So we can basically conclude the top professional working fields for these top 5 states with highest income is just going to be professional. And then lastly, once we've done all that work, then the question is just going to ask us to summarize it once more. And then this time it's just going to be Texas, Virginia, Georgia, and Illinois, and then finally Iowa. And then lastly, the most popular working fields in the 5 states, we just can put professional. Okay. Any questions for question 8? If not, we can move on to question 9. And then this one is basically just going to be like a repeat of like all of the other information that we did. So it should be pretty familiar by this point, but it's going to ask us to find the state with the highest male population. So as always, we're going to start off by asking for group by. So because it's asking us to find the state with the highest male population, we're going to start by grouping by. Then next, we're going to try and figure out which column that we're referring to. In this case, it's men. Then we want to sum up all of those amounts within those counties grouped by state. And then finally, the last thing we're going to do is sort values, and then also ascending equals false. So it's going to be pretty similar to all the other problems that we've done, but in order to do it, it's just going to be using the same format as before. We're going to use df group by. Then within square brackets, we're looking at state again. And then we want to add up the amount of men in these counties, and the name of the column is just men. So we're going to put men there. Then we're going to use sum to add up all of the amount of men within all these counties grouped by state. And then finally, we're just going to use sort values. Oops. And then ascending equals false. And then by the end, oops. invalid syntax around here. Oh, okay. Nope. Okay. Sort value's got an unexpected keyword argument ascending. Okay. So now it will give us the all of the counties grouped by state, and then it's going to sort them by whichever state has the most amount of men. And in this case, it's not Texas this time, it's California. So yeah, go us. But yeah, so we're just gonna put California in a string again, and then once we do that, we'll see that our answer has been typed in a string form, and we're done. All right, so once we've typed our answer in a string form, for the last question, we're going to be building off of the information that we did earlier, except this time we're going to find the state where male population is greater than female population. So while earlier we just found the state with the highest male population, next we're just going to find the state where male population specifically is greater than female population. And then it's going to give us 3 hints, but immediately from the question, you can basically grab like 3 components. The first one is you're trying to group all that information by state, so we're going to be using the group by function again. And then the second part is that we're also going to be looking at a specific condition where df male is, or df male.sum is going to be greater than df woman.sum. So you're looking at multiple components within there. And then the states are basically going to tell you or the hints are basically going to tell you the same thing. Again, we're organizing all that information by state level, so we're using group by, and it would be best for us to save the data frame so we can work with it again. And then secondly, we're using LOC function as before with a specific criteria, and then that way we can figure out the states with a greater male population. And lastly, the hint that it gives us is just that at the end of the day, we should be given 10 states that meet this condition. So in order to do that, the first thing that we can do is we can use the group by function. So like it suggests, we're just going to use, as before, df group by state again. So df group by state. And then, as you can suggest, once we have df group by state, then another thing that we can consider is that we want to find the sum of male and female population at state levels and then save that in a completely different data frame. So can anyone guess how to save all that information based on sum in a different data frame?
Sorry, what do you mean when you say that you're saving it in a data frame?
Yeah, so like earlier for question 4 and like I think question 6 or question 7, you'll recall that we basically found a specific condition that we wanted to look at, or like a specific column or type of data that we wanted to look at, and then we just saved it as a separate data frame. So we're basically doing the same thing now, except we want to figure out how to make the different data, or like since we want to make a different data frame called total pop, we just want to figure out what's on the other side and how to basically put all the information that gives us the sum of male and female population at state levels and save it as a completely new data frame. Sorry, that was kind of convoluted. I just mean that like earlier, if you look at the data frame, it's going to have all this information that we don't really need. And we just want to basically add up the amount of men and women in each state and then just have that as one data frame without all of that other stuff. So what the question is asking us is just what do we put total pop equal to in order to only have that information in the data set? Does that kind of make sense? Like more or less? Okay, cool. So then, yeah, basically as before, we're using the group by function by state, except this time, again, we just want to find the amount of total men and women per state. So in order to do that, as you've probably already guessed, we're just going to be using the sum function. And like before, where we used the group by function to add up the total amount of men, this time we're going to do it for both. So in order to do that, we're just going to be basically using commas. So we're just going to put not just men this time, but also women. And then finally, we're going to add up all that information in total by state. And then that way, indexing with multiple keys. Okay, I think it's fine. Sometimes it will give you like messages like that, but I think once we call total population, we'll see that the code works, and we can see all of that information of the total amount of men and women in each state organized as one separate data frame. So by doing this one step, we're getting rid of all the other bits at the earlier part with county, for example, like income per capita, voting age, citizens, race, all of that stuff has been deleted. And we're only looking at those two variables added up by state. Okay, so once we have this new data frame, the next thing that we have to do is we have to use LOC function and a specific criteria in order to find out the states with a greater male population. So can anyone guess what we would put within the square brackets to find the specific criteria? Hint is in order to reference the amount of men and women in a state, we're just going to be using total pop men. So can anyone guess the rest of the condition in order to figure out if men is greater than women within the population? Okay. We're just going to be basically doing the same thing where we put total pop women. And basically that will give us a condition where you're comparing the total population of men and women within the state and seeing whether or not the total population of men is greater. And then, as you'll recall, the LOC function is just going to get rid of any data within your data frame that just doesn't fit that condition. And then now you'll see that there should be 10 states here, which is Alaska, Colorado, Hawaii, Idaho, Montana, and then Nevada, North Dakota, South Dakota, Utah, and Wyoming. And then there is 10 states. So in order to do that, we're just going to type the rest of them here. And we can just do that by hand. Typing Alaska, Colorado, Hawaii, Idaho, Montana, Nevada, North Dakota, South Dakota, Utah, and Wyoming. And then finally, once we press play, then we have our answers all in a string form. And then that basically wraps up the homework. All right. Are there any other questions regarding like any of the concepts that we discussed within the homework? That can be like any of the functions that we used, how to solve those specific problems, or any of it, feel free to ask.
I was getting a lot of like syntax errors and stuff. Is there a place where I can see your answers to refer to so that I can figure out what I'm doing wrong?
Yeah, sure. I can save this notebook as like a separate notebook and drop it as a link. Let me see how I can do that. If I save a copy in GitHub, or I can do it in both GitHub and Drive. Okay. If I just put it in faster. Okay. I'll also do it in Drive in the meantime. Okay, yeah. All right, so yeah, basically this should have all of the solutions in there. If you have a lot of syntax errors, don't get like super discouraged. Honestly, like you said, or like you saw when we were within the live stream, there were a lot of times where like I messed up with syntax errors as well. And you kind of just have to like mess around and be familiar with it. Like it can be anything as like a lowercase letter or an uppercase letter, or just forgetting like a set of curly brackets or square brackets or anything like that. But yeah. As long as you can kind of get the general gist of how to put those things together, then that's all you really need.
Okay, great. Thank you.
Okay. I'll also drop the drive link if anyone's having trouble with GitHub. Let me. Okay. This one's been made a copy, so this should also work. All right. Okay. That should also work. If either of those links don't work or any of those stop working, just feel free to contact us, or either within BitProject or like the Slack channel or any of that. Okay. Is that it? Are there any other questions? All right. If not, thanks for watching. If you stuck around, if you even got like 50% of that, that's already like pretty impressive, since this is like a lot of content in just like 1 week. But yeah, if you've gotten any of that, you can give yourself a pat on the back. But thanks for watching, and yeah, bye guys.
Thank you.